Hi, welcome to the Water Research Foundation webcast. Your water system is not isolated. Interdependencies are important. My name is Jian Zan. I'm a research program manager with the foundation, and I will be moderating today's webcast. Before we start, we have several housekeeping items to go through. Please send us your questions through the question box at any time. We will do a Q&A at the end of the webcast. Slides and the recording of the webcast will be available for download from our website. The link is here. You can download the slide now and access a link to the project page on the events resources on the bottom left of your screen. A certificate of completion will be automatically generated at the end of this webcast. And lastly, it's important for us to hear from you regarding today's webcast, so please stay until the end to fill out a quick survey. So this webcast will be presenting results from the Foundation Project 5086, Case Studies on Water Sector Interdependencies. I want to mention that our partner in Australia, the Water Services Association of Australia, they co-funded this project and encouraged Australian utilities to participate. And Heather will be talking about that in her presentation. So now I'd like to introduce today's presenter, Heather Himmelberger. She was the principal investigator of this project. She is the director of the Southwest Environmental Finance Center, a position she has held for the past 28 years. She has worked with water and wastewater utilities of all sizes on a variety of issues, including, but not limited to, capacity development, asset management, water loss control, rate setting, access to funding, infrastructure development, and regulatory compliance for the past 37 years. Heather is a registered professional engineer in New Mexico and Pennsylvania. She has a bachelor's degree in environmental engineering from Penn State University and a master's degree in environmental engineering from Johns Hopkins University. With that, I will hand this over to Heather.
Hi, everybody. Can you hear me okay? All right, well, welcome everyone. And I wanted to say, first of all, the project name of interdependencies, as Jan was sort of tripping over that word, I do it all the time too. So probably throughout this presentation, I will be tripping over the interdependencies. It's a tough word to say. But I wanted to put on the screen the project team. We certainly had a lot of help in doing this. We had a project advisory committee. We had some project advisors. And then I wanted to acknowledge our lead researcher, Frank Roth, who was with us until recently. He moved to the American Water Works Association. So I want to thank him for all the hard work that he did on this project. I also want to thank our participating utilities. We had 16 utilities from 4 different countries participating in this project, and that's, great. And we thank everybody for being so willing to share information and being so open and willing to tell their stories. We had 3 Australian utilities that joined in July 2021, and that came with the additional funding of the Water Services Association of Australia. And almost all the utilities provided water and wastewater services, but there were a few that were either just water or wastewater only utilities, and a few were also part of organizations that also provided energy, and about half of them provided drainage or other stormwater related services. Therefore, that one water concept, and one water is water, drinking water, wastewater, stormwater all together. That one water concept was a big thing for many of the utilities and came up in the discussions. We did have 2 project deliverables. So the first deliverables was a compilation of case studies on existing utility practices for determining risk-based organizational interdependencies. So kind of working with those large utilities. So we had, in pretty much all cases, they were large utilities, although some did have some element of rural services as well included. So the first task was to get their stories, to understand what was going on, compile those, analyze those, and create this document that kind of shares all that knowledge that we gained. And then the second task was to come up with a small to medium-sized water utility guidebook to kind of bring those experience of the large utilities down to the small utilities. And we're going to talk mostly about the case studies today, but we are going to get into the small and medium-sized water utility guidebook towards the end of the presentation. So again, we're going to start by focusing on the case studies and go through a lot of that material first. So we need to think about what are the interdependencies that we're talking about. So we wanted to think about the fact that water utilities are systems of systems, and they're complex, interlinking, and bidirectional relationships with many different kinds of sectors. And these sectors are also lifeline sectors, so it's important for us to know how the sectors work together. So how does water affect chemicals, communications, electrical power, transportation, natural gas, and petroleum? So those were the main lifeline sectors that we were dealing with in this project. Oops. So the chemicals are required to operate water and wastewater treatment facilities, and water is often needed for chemical manufacturing. In communication, that sector relies on water for equipment cooling and facility operations as they're making their equipment, while the water sector relies on communications and information technology for their operations, monitoring, and control systems. In power, the energy sector relies a lot on water services for different aspects of energy production and generation. And the water sector relies heavily on energy to move water, to treat water, to do these different things. And specifically, electricity is needed to operate pumps, treatment facilities, and delivery systems. In transportation, we transport the materials that we need, like chemicals and other supplies, generally delivered by truck and rail. And we also need the water sector personnel to rely on the transportation network to get to and from work and then around the work site. So often utilities can be fairly large, and it's important for us to know or to be able to get around those work areas to using the transportation networks. And fuel is requires water to extract oil and natural gas from its underground source and then transform the fuel's chemical energy into electricity. And then the water sector relies on fuel for backup power and fleet transport. So let's get into why these interdependencies can be messed up. So one of the things is we wanted to look at how these sectors work together to plan, respond, recover, and adapt to what we call black sky events. Black sky events are high impact, uncertain probability events that can cause a combination of severe physical damage to infrastructure and widespread long-term duration outages. And since the beginning of the project in early 2021, utilities were dealing with more frequent and severe events. And of course, we all know during that time also, they were dealing with one major one that affected everybody, which was the pandemic. And the shocks and stresses of black sky events like to disrupt those connections between the water sector and other sectors. So when we were interviewing the participating utilities, there were many discussions on how they plan, respond, recover, and adapt to these black sky events. And from those discussions emerged some common themes. And we used those common themes to create this document and put them into 6 themes, which became modules or chapters in the report. And they were based on the utility examples of how they absorbed, adapt, and capitalize on the shocks and stresses that they were exposed to. And about 70 case study examples from all the utilities that I mentioned in the beginning of the talk were included. And the fundamental practices module focuses on the major critical infrastructure or lifeline sectors that we just discussed, like power, fuel, chemicals, transportation, and then the subdomains of operational resilience and water availability. And we are going to focus on those. We're going to focus on the fundamental practices today. So one item we heard from the project advisory committee as we were going through this project is that we need to really think about the practical steps that systems could take in moving from where they are today to where they might want to be in the future. So they wanted to have a way to look at what are some basic practices, what are intermediate, and what are advanced practices. So where might you be today? Where could you move through? And they also wanted to have options, menus of options for utilities to deal with, because utilities are unique and they want to be able to consider what best fits them depending on their size, type, or location. So we wanted to have these different options to kind of allow utilities to pick what would work best for them. So here's an example of these maturity levels for the energy sector. So you can see there's different practices that make up a basic, intermediate, or advanced. And so looking at the advanced, you can see like multiple layers of renewable power, power supply, wind, solar, or biogas. That's not something that you would take on right away, but you might, move up to that to have all these different layers. So again, it was to give utilities a chance to go from basic to intermediate to advanced. So when we got to some of the other sections that were not those basic ones, the module was a bit different because it didn't really lend itself so well to the maturity levels. So we decided to go by looking at benefits, consideration, ideas, and utility insights. So here's an example of the asset management resilience practices module. And I should mention that asset management maybe was not what we originally intended to put in, but so many utilities are engaged in asset management, and so many of them pointed to asset management as being one of the things that really helped them achieve what they needed to with, the interdependencies and trying to be resilient, that we decided to include a chapter on asset management. So you can see like one example of a benefit was it improves interdependencies with other lifeline sectors and service delivery. One consideration example was use business intelligence and dashboards to visualize the availability of assets. And one idea example is develop and conduct annual assessments on the resilience of assets to impacts of climate variability and black sky events. And then two highlights of interviews from utilities were adding resilience and redundancy to projects as part of the cost of doing business, and find a funding partner to help move resilience-directed projects forward. So in the document, there were 7 key findings, and I wanted to talk about each of those because we think they're very important for utilities to understand. The water sector utilities that strengthen their relationship with other critical infrastructure or lifeline sectors improve their ability to prepare, respond, recover, and adapt to black sky events or hazards. Water sector utilities prefer a menu of options and practical steps in improving capabilities and operational resilience. Partnerships with other lifeline sectors support utility operations through communicating and sharing of resources, information, or technical support. As utilities improve their capabilities, workforce culture can improve through increased experience, internal knowledge, competency, and skills, which may result in reduced cost and increased efficiency by fostering creative and innovative ideas. Enhancing operational capabilities can build organizational agility and enable better decision-making and improve quality of service delivery. Aligning asset management resilience to interdependency practices may reduce business risk exposure and improve reliability, redundancy, response, and recovery. And finally, documenting past experiences and solutions improves knowledge and understanding of past events and the application of solutions and alternatives excuse me, to improve response and recovery. And I think this document is really, the documents we created is really part of this whole process of trying to share these solutions and trying to help people understand the situations they were in the past and what might affect them in the future. So what we're going to do now is share a few examples for each of the sectors, these interdependencies, from a variety of case studies. And I tried to be picking case studies that were geographically diverse and system diversity, so that hopefully you could hear at least 1 or 2 stories throughout this presentation that connect with you. There are, again, 70 case studies in here, so there's going to be way more than we're going to cover today, but I just wanted to share a few for each one of these so you can get a flavor of what the document has in it. So we're going to start with the energy, and energy is basically the most important sector. That's where we see the most critical ties between water and energy because they each need each other. And when one goes down, it affects the other. So then that in turn affects, keeps making things worse. So energy is one that's probably the most important for us to be thinking about the interdependencies. So East Bay Municipal Utility District is the first case study we're going to talk about, and we're going to talk about public safety power shutoffs. Not everybody experiences these, but these are cases where the high winds or some other condition may require the power company to shut off power to prevent some, serious fire or some other conditions from happening. So they're going to shut down the power and they can let people know the power is going to be shut off. So the way that East Bay MUD mitigated public safety power shutoffs was with portable and on-site generators. And on-site generators are used for key treatment and distribution facilities. And portable generators and pumps are ready to be deployed with electrical connections or pumping tees. And the utility also contracted with local suppliers to provide additional generators if needed to meet their needs. In some instances, the generators are pre-deployed during wildfire season based on the pumping plant's location in the wildfire area and the expected time for reservoir to drain if the pumping plant is out of power. In addition, regular training and exercises are conducted to practice the deployment, connection, use of generators. When a red flag warning is issued by the National Weather Service, the utility will ensure finished water reservoirs are full in case there is a shutoff, and also to support the firefighting. Another thing that they do is talk to their customers ahead of time and try to ask them to limit water use and limit outside watering during these high-risk periods. And they have seen a reduction by customer usage, so they know that the customers are listening when they do this. So San Jose has a strong relationship with its power utilities and the petroleum refineries in the area. And understanding these relationships is an important part of their resilience. And again, coming back to that idea, water needs energy and energy needs water. So they have a network of stationary and portable generators in place to keep water flowing. And they have a cloud-based monitoring network that monitors this type of power. And with over 65 on-site generators, the monitoring data is critical to them to help them monitor and assess the health of their emergency power network. And they also have portable generators with GPS and electronic logbook. And they work with the California Water Wastewater Response Network, which is WARN. And if anybody out there is listening and you're not part of your WARN in your state, and I think just about every state has them, that's a great place to go to kind of get help in emergencies, and then for the larger utilities to help out in running those kinds of organizations. In Toho, Florida, they're a little bit different. They have on-site generators at plants and master lift stations that are critical facilities in moving the wastewater through their sewer system. But unlike San Jose, they don't maintain a large fleet of portable generators because they have over 450 lift stations. And maintaining and testing such a large fleet of generators would be really difficult. Instead, it follows the standard of maintaining 10% of facilities on generators during a widespread power loss event and utilizes a sewer basin pump drawdown schedule to prioritize and rotate the generators. The utility also uses portable bypass pumps, which are more flexible and adaptable than portable generators. So just slightly different way of dealing with the same kind of problem. And again, to give you the idea that there are more ways than one to address your situations that you're dealing with. Now we're going to move on to fuel practices. So East Bay MUD reduced its fleet emissions by switching to renewable diesel, which was a cleaner burning renewable fuel domestically produced. And DC Water contracts with DC Public Works Department, which developed a fuel mapping strategy to assess fuel from several sources and deliver fuel based on the district's priorities. So DC Water reached out to their vendor to determine any potential supply issues, engaged their procurement office in developing emergency and alternative vendors. San Jose upgraded several field vehicles to have double the fuel capacity so they could stay in the field longer doing the work that was needed to be done. In an emergency, that can be super important, especially if you have a large distribution system where you're going to have to get across quickly. It's really important to have that extra fuel capacity. And the generator inventory can be supplemented with fuel calculation chart to understand how the fuel is being used. Now we're going to move on to chemicals. So in Austin, Texas, they typically keep a 2-week supply of chemicals. And they also have some operational strategies to conserve chemicals without affecting water compliance, water quality and standards. And in 2018, they had a flood that led to changes in their chemical practices to better prepare for these kinds of disasters. And the water usage can increase immediately before and immediately after a disaster, which can also increase chemical needs, and that's something they needed to keep in mind. And additionally, high turbidity water can also use additional chemicals. So if the water quality is being affected, like in this case by a flood, they may need extra chemicals just to treat the water to the condition it needs to be in. And then they have a comprehensive and complete chemical inventory control to inform the utility of current usage and current supply so they can better prepare for any impending event. And they've also identified non-local suppliers and secondary suppliers and distributors to make sure that they have redundancy if there's any water supply change issues. In Portland, Oregon, there was a chlorine supply issue that impacted drinking water and wastewater facilities in 2021. And if you remember, that was also a time of COVID, so there were other issues going on at the same time that affected supply chains. But this was a major production failure at one of their chemical suppliers that served most of the West Coast. And they normally receive daily deliveries of sodium hypochlorite, and depending on whether it's wet or dry weather, they may need more or fewer chemicals, which will affect, how much storage, but it's always fairly short. So the shortage occurred when there was already this national production and shipping issue, so that compounded the problem. So they activated their emergency response plan and engaged both water and wastewater bureaus because both of them were affected by the chlorine shortage. And the teams had to work together to optimize and minimize use of chemicals until the supply was available. And during that time, they met regularly for emergency briefings, and they both implemented strategies to conserve hypochlorite usage. And the two bureaus realized that there is a need to develop a structure and mechanisms for sharing of the critical chemicals as well as delivery systems. And they're developing chemical supply contracts with multiple suppliers and multiple sources to avoid relying on a single chlorine provider. And I wanted to share this slide just to show you that within the book, there are pieces of information from these case studies that really help inform a lot of what they were doing. So you can also get little tidbits of how they practice certain things and charts and graphs and things that were used by the various utilities as part of their recovery from events. Calgary, Canada, in the summer of 2020, they had railway blockades that impacted the transportation of chemicals used by the city of Calgary's water treatment plants. And the blockades led to the shutdown of the rail network, causing a complete halt of freight traffic from Halifax west to Toronto. And the spring prior to the blockades, the utility was in close communication with suppliers because of COVID-19 issues affecting supply chains. And aluminum sulfate is the most important chemical used by them as a coagulating agent in the drinking water purification process. And the utility purchases large quantities of the chemical and is highly dependent on it, especially during the spring runoff season. And the raw materials come from Quebec and are transported to Calgary, where they're processed by one of the utility suppliers. The utility can only store a few days' supply of this critical chemical, especially during the spring runoff period when the demand significantly increases. The utility worked with the chemical manufacturer to develop alternative solutions or secondary suppliers. Blockades came down after Canada's medical officer advised against gatherings as part of the pandemic. But they have these plans ready to go if similar issues occur in the future. Another chemical supply issue for Calgary occurred in 2019, and salt is used to produce their sodium hypochlorite, and it's another important chemical in the treatment disinfection process. And their local supplier had several issues in supplying the salt to both Calgary and EPCOR in Edmonton. So Calgary worked with EPCOR to locate a secondary source in the United States that was willing to truck supplies north to the two utilities. And working together, they managed the situation until a new distributor was found. However, learning from this experience, they established a backup plan to use liquid sodium hypochlorite so that they could have a way to address the situation if ever they couldn't get the salt. And one of the themes that you'll hear in many of the stories as you read the document is partnerships and how important different types of partnerships are as they try to recover and mitigate disasters. Next is transportation. So Atlantic County Utilities Authority has a incinerator that accepts biosolids from a lot of other utilities in the area. So they had anytime a disrupted transportation network occurs, that affects the hauling of biosolids. So during long-term storm events, utilities have to be able to store the biosolids until they can be safely transported. And that's one where generally those could be smaller utilities, so they need to understand the need to store prior to being able to ship it to Atlantic County. So anytime that's the kind of situation you have with your utility, you need to think about what would happen if I couldn't deliver whatever it might be to the next utility over. In Portland, wildfires affected Portland's ability to haul solids from their treatment plant because of closed transportation routes. And the utility had limited capacity to store biosolids at the plant. Generally, they land apply their biosolids in dryland pastures in the eastern part of Oregon, where it's semi-arid, and that allows for year-round processing of biosolids or year-round land application of biosolids. However, there are limited transportation routes to the eastern part of the state. So learning from this experience, they needed nearby alternative sites where they could temporarily store biosolids. So they've now acquired those. And then once the transportation routes are over, they can move the solids where they need to be. And they learned the importance of real-time monitoring analysis of solids inventory. And when necessary, they've issued an emergency order to hire a contract for additional solids processing and transportation. In Austin, Winter Storm Uri really affected them. And if you remember back, if anybody remembers those days where it was very, very frigidly cold in Texas, like unusually so, and because of that cold, stormy, icy weather, it did affect transportation quite a bit. So many Austin water personnel were unable to report for work assignments because of these poor road conditions. And because that type of storm is very rare, the utility did not have a ready fleet of vehicles capable of operating in these extreme weather conditions. So they had to get ad hoc ride services provided through the incident management team. And learning from this issue, the utility began to evaluate options for developing fleet assets that enhance response capabilities during emergency conditions, including purchasing toll road tags for high priority fleet vehicles to improve response time. They've also purchased tire chains for their vehicles and conducted training on how to use the chains. And these have helped them prepare if there is another storm like that, they need to be ready for it. Next, we'll move into communication. So in Western Australia, only the Hazard Management Agency is allowed to communicate when there's an emergency declared, and that's under their Emergency Management Act 205. And therefore, the key for the Water Corporation in Western Australia is focusing its messaging and conveying the importance of saving water. And the utility avoids using the term crisis in responding to major events or hazards. Instead, it manages these incidents under business as usual and a sort of we will get through it together message that it gives to its customers. This next one combines a bunch of different utilities because they all had very similar kinds of issues. So many of the participating utilities have switched from radio communication systems to cellular. And there are many benefits of cellular systems in terms of information and workflow capabilities. However, during power outages, some cellular towers have backup battery power for only 4 to 6 hours. While most cellular networks have some level of redundancy in their coverage, removal of a single major tower in an urban area can have a significant impact on the ability to handle cellular traffic. Not being able to communicate to field staff becomes a significant issue during longer-term power outages. Some utilities noted the ability to use Emergency Operations Center radio systems to stay connected to emergency operations and other critical sectors, but that's typically limited to just incident team members. Because of poor cellular signal strength, Northeast Water uses satellite phones to stay connected to their rural water facilities during emergency events. East Bay Mud and DC Water have radio and satellite capabilities at their mobile command centers as shown in the picture. Portland's trunk digital radio system has been built with significant resilience and redundancy, such that it is expected to be the primary mode of public safety communication during or after most disasters. However, continued radio system operation depends on the microwave relay and wired IP networks that connect the repeaters together remaining operational and the availability of sufficient fuel to drive on-site generators. Portland's Emergency Coordination Center has multiple redundant communication systems, including a large backup generator, solar power, satellite internet access, satellite telephony, and both public safety and amateur radio operations facilities. It's designed to support large multi-agency emergency response and facilitate cooperation and interoperability among city, county, and state federal officials. So again, there's a picture of some of that mobile command. And it's important to remember that communications is not as reliable as one might think. And just a short aside, I was in Vermont during the solar eclipse recently, and cellular service was down for a bit because it was so overloaded with people. So again, remember that the cellular functions aren't maybe as reliable as we would hope. Moving on to operational resilience practices, we have a DC Water case study. So DC Water benefits from assistance from this 249th Engineer Battalion. It's also known as Prime Power, and they can request this through the local emergency management agency. And it's a federal relief power provider, and it can provide commercial level power to military units and federal relief organizations during full spectrum operations. And they assisted DC Water with an assessment of power needs at numerous DC Water facilities in conjunction with the National Capital Region Power full-scale exercise. So again, doing one of these exercises can be a great way to try to see what you're vulnerable to, and they helped in that. So the training exercises also include its energy supplier, PEPCO. And PEPCO and DC Water work together to provide dual feeds at critical facilities, and they often review the joint power prioritization plan. And while many of you will not be able to have a partner such as this 249th Engineer Battalion, it is important to remember that you need to be creative in thinking about your potential project partners in this, because the partnerships may come in unusual places, such as this Engineer Battalion. All right, next we're going to do Northeast Water Victoria, Australia. And for Northeast Water, the impacts from climate change have increased the frequency and intensity of major storm events in Victoria. For this reason, the Regional Emergency Management Team meets monthly to prepare for these major events at incident control centers. Northeast Water is a member of this team, which also includes firefighters, ambulance, police, school, and state agency. The water utility uses emergency management liaison officers, EMLOs, who are active members and regularly engage the other critical sectors. During the 2020 bushfires, EMLOs coordinated with fire suppression crews to protect critical drinking water assets. They also coordinated with the Army, who protected critical lift stations by removing debris around the facilities and wrapping the buildings in heat-resistant foil, as shown in the picture. So in this picture, you can see the foil that they put around the facilities to try to protect them from the fire heat. Water Corporation in Western Australia developed a resilience culture, and they want to be in complete control of what happens to them. And because of extreme isolation, the utility has to be masters of their own fate. And their key to successful resilience planning involves three components: communication, cooperation, and coordination. Frequency and severity of black sky events led to an annual pre-preparation practice. And events require more rigorous contingency planning, risk assessment, and prioritization of asset systems to ensure that the most critical facilities have adequate power, chemicals, and supplies for potential events. Partnering with the oil and gas industry to use, they also partner with the oil and gas industry to use helicopters to drop their teams at remote sites to work on facilities. And I think this is another really interesting partnership where you might not think of using your power companies to get your employees to remote locations, but if transportation networks are blocked, this might be a good way to get your people where they need to go. Next, we're going to look at water resources, supply, and availability practices. So East Bay Mud and San Jose both have interconnections. So East Bay Mud has interconnections with 3 neighboring utilities that allows raw or treated water to flow between any of the systems. And they do regular testing of the interconnects to make sure that they're all working well. San Jose Water has several interconnects, and the interconnects can be from either higher or lower pressure. So they have to have vaults and connections to allow either a regulator or a pump to be installed to address either the lower pressure or the higher pressure transfers. East Bay Med can also partner with other utilities in the Bay Area to provide raw water to address emergencies. So San Jose conducted a well supply capacity evaluation that evaluated the ability of its groundwater well infrastructure to deliver sufficient water to meet future demands until 2040. And they use a contracted water supply from Valley Water for a varying percentage of its water supply needs. However, if the supply is impacted by drought conditions, it can increase groundwater use consistent with its urban water management plan. Greater variability in the availability of surface water supplies caused by climate change are likely to occur in the future. And to allow surface water to be used during as much of the year as possible, San Jose Water has a considerable watershed and stores water in upstream reservoirs in the winter months and releases flow downstream to be diverted to treatment plants in drier months. In Kansas City, they have an intertie agreement with regional water utilities, and the utility is part of 6 utilities in that region that coordinate through the local emergency planning committee. Through the partnership with nearby utilities, they're able to assist with potable water interconnections, as well as parts, chemical supplies, equipment, and people. This group also provides a mechanism to coordinate assistance with other lifeline sectors, including public health and safety, hospitals, transportation, and community groups. So we're only able to get into a small part of the case study document today. There's a lot more to the fundamental practices, and remember the document has a lot more themes. I encourage you to look at the document and read the other parts. And as I mentioned before, there's about 70 case study examples from all the utilities, and they're included in each of those themes throughout the book. And so there's so much more that could be said, but unfortunately with time, we can only cover so much, and we can only touch the tip of the iceberg here. But I'm hoping that if you're interested in these case studies and interested in learning more about these various utilities and how they handle the black sky events, that you'll access this document on the WRF site and go through it and find the themes and the case studies that best match what your needs are, the kinds of black sky events that you are subjected to, and use that information to help you as you move forward. Now we're going to move on to focus a bit on the guidebook. And so we used the experiences of the large utilities to inform what small to medium-sized water utilities might need to do to manage their own cross-sector interdependencies. And it's important for us to remember that even though we focus the case studies on large, that small to medium-sized utilities are subjected to the same kinds of things. They're in the same areas. They're, face black sky events as well. So it's really important to try to figure out what we can do to help them. So it's important to say what a small to medium-sized utility is, and they are different from different countries. So in the US, a small utility is generally considered one that's less than 10,000 population, and very small is typically considered less than 3,300. Medium in the US is considered about 10,000 to 50,000 people. So in Canada, it's about 500 to 5,000 is considered small. And in Australia, small is considered less than 1,000. So you can see there's quite a variation. Generally, the guidebook is meant for any system serving less than about 50,000 people. And there's no hard and fast rules. A smaller utility could use it, if they're teeny tiny and they want to do something, that's great. If a larger city sees something in the guidebook they want to use, that's fine too. But just remember, in general, the idea was to serve that population that was less than 50,000. So the purpose was to really, pass on the large utility information to small and medium-sized utilities. And, oftentimes we develop these infrastructure networks in isolation. We're not really thinking about how does power affect water, and how does communication affect that, or how does transportation affect all of it. So we're developing those in isolation. But with modern technologies and demands, we really have this unprecedented degree of complexity and interlinking between what we used to think as disparate networks. And because of this interconnectivity, water systems really function as a system of systems rather than isolated water systems. So we have to be very careful to remember that. And it's something that probably small systems are less able to think about or less maybe on the top of mind for them. But it's true for all water utilities and wastewater utilities, stormwater utilities. We're really systems of systems, and we need to remember how we are interconnected. And the same water sector interdependencies that we talked about with the case studies is what is included in the guidebook. And then we also have the additional topics: operational and workforce resilience, water resources supply availability practices, partnership practices, and asset management resilience. And while there's less going on in the practice of asset management in small utilities, it is a practice that is occurring. It's one that's being encouraged more and more. So this might be a way to kind of do both things at once, to build asset management resilience and as well as resilience to black sky events at the same time. We did use the same black sky events because it's really not different between small and large. It might be degrees of how, maybe it's less likely that there's a cyber terrorist event at a small utility, but it's not impossible. So we did include all the same kinds of black sky hazards and events. And similar to the idea with the case studies, that there needs to be a menu of options and ideas, because not everything is applicable to every system. So it's an opportunity to choose what fits best in the context of the system, address the most likely black sky events for that system, understand those interdependencies that are most important to that system, and strengthen organizational resilience. So in the document, there are practice levels: standard, advanced, standard and advanced. And the standard ones are for small systems and medium systems, and advanced is mostly for the medium-sized systems. Again, there's no hard and fast rules. They can use any practices they want, but it was meant more that the standard practices were for very small and advanced was for medium. And then every section has resources along with how to access them, where they're from, what organization, et cetera, to help systems as they're trying to put these practices in place. So I only picked one example for each of these because, again, there's lots and lots of them, but just to give you a flavor of the kinds of things that are included in the document. So for energy, a standard practice is to maintain generator spare parts and materials. An advanced practice is co-resilience planning with energy sector to decrease recovery time. And a resource is the incident action checklist for power outages, which gives information for utilities to prepare, respond, and recover to power outages. With fuel, a standard practice is to have written procedures on fuel delivery arrangements, and an advanced practice is to develop fuel mapping strategies and supply chain alternatives. And a couple of resources, or a resource, is lessons learned from Superstorm Sandy. So of course that had a huge impact on utilities in that area. So they created a pretty good lessons learned document that has a lot of great information. With chemicals, the standard practice example is develop partnerships to share chemical needs with neighboring utilities. And you saw that in the Canadian example, where the utilities had to work together to address their needs. And using chemical optimization to determine the lowest level of chemical dosage. So if we can try to change our practices so we don't have to use as many chemicals, but still achieve the treatment that we want, that can be a great thing to do. And one of the resources is Supply Chain Resilience, a guide for water and wastewater utilities. In transportation, a standard practice is to training for driving and using emergency equipment in inclement weather conditions. And that training is super important, because if you've never used chains before, you can't just figure it out on the fly. You have to have the training. And develop transportation route alternatives for service delivery. And then the National Infrastructure Advisory Council's Transportation Sector Resilience is a resource in that section. For communication, developing risk communication procedures with template messaging that is brief and easily understood for all customer classes. And advanced ensure incident team members have radio capabilities or have access to the local emergency communication system. And a resource is water utility communication during emergency response. Again, there are many more resources in the book. With operational workforce resilience, we have utility-to-utility partnerships or agreements. And then for advanced, conduct training exercise with other lifeline sectors. And training is a really big one that lots of utilities in the case studies talked about. And then emergency response and contingency planning for small water systems is a resource that can be used. For water resources supplies, a standard practice was to establish partnerships and mutual aid agreements with neighboring utilities to share resources. And you heard some of that discussed in the case studies earlier in the presentation. And then mapping high-risk areas that could be impacted from black sky events, and install and regularly test isolation valves. And then an integrated supply network maturity model, water scarcity perspective is a resource there. And then for partnerships and asset management, similar to the case studies, instead of using the approach we did for the other sectors, we did a benefits, ideas, and considerations. So for partnerships, one benefit is supports utility operations and planning for, responding to, and recovering from black sky events through sharing of resources, information, or technical support. And one consideration is that partnerships can be between utilities, governmental entities, educational institutions, private companies, or nonprofit research organizations. And an idea is, if a network does not exist, create your own partnership with nearby communities and establish regular meetings with staff support. For asset management, it improves reliability, redundancy, response, and recovery. And a consideration is to conduct condition assessments to determine level of high-risk assets. And an idea is to evaluate capital planning alternatives that include resilience factors to improve redundancy and reliability in black sky events. And I have my contact information on the screen. You're welcome to contact me after this event is over if you have any questions or issues or anything you want to know about the project. And again, it was just an opportunity to kind of whet your appetite a bit and have you go look at the documents, because there's no way in an hour we can cover all that was done in a couple of year period and interviewing all those utilities. And again, I just thank the participating utilities so much for their willingness to work with us.
Great, thank you, Heather. So now it's time for a Q&A. You can type in the questions now. I think we have several questions already in the box. Heather, let me read out the first question to you. So did you look at the use by utilities of more distributed systems rather than those large centralized systems to reduce asset management costs by locating the supply closer to the demand and increasing resilience by spreading out risk to system failure during a black sky event?
Sorry, I was muted. I think there's a lot to be said for looking at resilience in those ways. Like, how can you separate out critical facilities so that maybe you have a bit of redundancy? So even if you have systems connected, is there a way to maybe cut that connection if that's necessary? So definitely, as you're planning for black sky events, that is something that should be considered, is what makes the most sense for the types of black sky events that you might be subjected to. And that should certainly be part of future planning, is whether that could make you more resilient or not in your particular area. So of course, every utility is unique, but looking at that as an option is something that could definitely be, part of a resilience strategy.
Great, thank you. So next question is about sciences. So I know several social and natural sciences have an interest in theories of resilience of systems. So adaptive capacity in ecology comes to mind. Are any of these theoretical perspectives informing your analysis on these case studies?
I would say we didn't go lots into the theoretical. We really stuck as much as possible to the experiences of the utilities that we interviewed. And we actually interviewed more utilities than we originally intended to at the start of the project. We were able to bring in some more utilities through the project. And some had experienced events that helped us talk to them. So I would say that the majority of the work was informed more by the experiences of the utilities and less by theoretical. I won't say that none of it, from the theoretical perspective was included, but it was very much informed by all of the experiences that the utilities had and, all of their stories that they shared with us of what happened and what was good and bad. And they were very frank with us about, sharing both the goods and the bads. And I think that's a real key critical thing, that anytime you go back and assess yourself, you have to be very honest about what worked and what didn't so that you can improve for the future.
Great, thanks. So next question, do black sky events include climate change?
I would say yes, in a way. So we didn't include climate change as like a specific black sky event in and of itself, but climate change has created worse black sky events. So in that way, yes, it is definitely included. So climate change, climate change has caused like greater storms, more intense storms in some areas. It has caused greater droughts and more intense droughts in other areas. It has led to more wildfires. So in that way, I think all the black sky events, or many of the black sky events, are informed by climate change. So we didn't use climate change as a separate one, but rather it's just part of the intensity or the intensifying of these black sky events that are already included.
Great, thank you. So you mentioned several factors, interdependencies, fuel, transportation, communications. Which one of them, which interdependency was found to be the most critical?
Energy, by far. No question about it, that is one that is so bidirectional. So energy needs water, water needs energy. So those two are so intimately connected, and they also have the most impact on each other. So that was by far the most critical one, and the one that really caused a lot of issues for utilities. So, and a lot of these mix and match. So if you have a black sky event that creates one type of disaster, it might lead to an energy issue. So a wildfire can lead to an energy outage, or, bad weather can lead to energy outages. So that one was by far the worst, although not to say the other ones aren't bad, but the most critical one is definitely the energy.
All right, thank you. So next question is, what types of utilities could benefit from reading the case studies and the guidebook?
I would say everybody. I would say there's not one utility out there that is not affected by a black sky event, or could potentially be affected by a black sky event. There's nobody, no matter where you are. I'm sitting here in New Mexico. We have a lot of isolated places. That does not mean nothing is ever going to impact them. We had some small utilities that used to think that, and then a wildfire came through and really, really impacted those utilities tremendously. So anybody can be subjected to a black sky event. And I think that we have to be cognizant of that. And so every utility everywhere should be looking at these and thinking about how they intersect and the different ways that they relate. So I think it's super important for everybody to consider that. And then plan and prepare for it, because you don't want to plan and prepare while you're in it. You want to do that before it happens so you know what to do.
Sure. Yeah. Thanks, Heather. So next question, aside from generators, are there other solutions to power resilience, potentially microgrids or DERs?
I'm not sure I know what a DER is, and I apologize for that. But yes, there are some other solutions that people talked about. And one is to have redundant power sources. from other types of power. So if you're connected to the electrical grid, can you have a solar backup? Could you have some wind backup? Is there other ways to get power? Are there other ways to get redundancies? So generators certainly is one of the most common ways that people are doing it, but looking at these redundant sources of power is another thing. There's a lot of work going on in like batteries and things, and maybe that one day will be sufficient to help us. You know, I don't think the battery technology is quite where we want it to be yet, but maybe someday. So yeah, I mean, that's a big one that people are using, but there are some other strategies discussed in the document that other, you know, some of these case studies are using.
Great. So the next question is, how would you suggest a utility get started with understanding interdependencies and becoming more resilient to disruptions in them?
So I think one of the first things that a utility might want to do is think about what black sky events they're most likely to have happen to them, and think about, again, the most critical infrastructure or the critical interdependency, which is the energy. So that would be a great starting place, is to think what might happen to us and be very open about that, because what's on front of mind may not be like the full gamut. So kind of really look around and see what are all the things that could happen and how might they affect energy. So maybe just start there as a beginning place, open the document, read the sections on energy and the case studies, read the section in the guidebook, and try to pick out a couple of practices that might work for you, you know, as a starting place. Are there neighboring utilities that you could start meeting with and say, hey, let's do this together? So I think one of the best ways would just be, you know, start somewhere and then work through the other interdependencies that there are. So one at a time, looking at those. It's too overwhelming to take it all on at once, but think about energy, which is the most important, and then maybe start thinking about, for you, is that next one transportation or communication or whichever, and start building in practices. And the more those practices get built in, hopefully you're more resilient, and then you can do more things because you won't have to recover from these events because you'll be ready for them, and it won't put you out of business for a long time.
Great. So the next question is about the workforce. I think you also mentioned that, but we didn't touch on any details. So did any utilities talk about staffing issues? Because the water sector in particular is going to see a large part of its workforce retire in the next few years. I would think this might also affect other interdependent sectors.
Yeah, we didn't go into the last part of the question of whether it affects energy. I'm assuming it does, but we did not actually look at whether workforce issues affect like transportation and communications, et cetera. But I would imagine that they probably are. But we did look in the workforce. We did the 4 pillars of workforce that we talked about were recruitment, retention, competency, and community partnerships. And so recruitment, which gets at your question, is part of that whole resiliency. How do we get a workforce? And once we get them, how do we train them and keep them? And it is a sector problem, and it is definitely part of the reason that operational and workforce resilience got in the document, is because that is a big part of it. So just having a workforce, and we just recently went through the pandemic. So we know that how that affected workforce too. So even if it's not the general issue of people not going into the workforce or retirees, but just how a black sky event like a pandemic can affect our workers, where they maybe can't come because they're sick or their family is sick, something like that. So yes, you know, recruitment and trying to bring more people is definitely, you know, part of the issue. It wasn't a huge focus given that we were trying to, you know, look at these interdependencies, but we do have information in both the guidebook and the case studies that relate to workforce.
Great, thank you. I think our time is just up. So yeah, I think that's all the time we have for the questions. So I really want to thank you, Heather, for the great presentation. And I also want to thank our audience to attend this webcast, and great questions. So please take the survey when you leave. Thanks and have a great day.
Thank you, everybody. Appreciate y'all being here today.